26.
Say,
Mm-hmm.
find all values for x for which the graph of h has a horizontal tangent and determine whether h has a local maximum, a local minimum, or neither at each of these values. Justify ranges.
All right. To find the local maximum or a minimum, or neither, we have to go ahead and set the numerator equal to 0 and the denominator equal to 0. But do you guys already see that it's already derived, h prime? Yeah? So I can go ahead and say, oh, all that room. I'm going to go up here. 0 is equal to x squared minus 2 over x. So if I set the top equal to 0, that's going to give me my critical number at the following. It's going to be plus or minus radical 2. Because we're adding 2 on both sides, square rooting, and when you square root, you get plus or minus. And then the other critical point, let's just say x equals, by the way. The denominator equal to 0 as well. So we have 3 critical points. And it looks like for this one, did it give us restriction on the domain? Nope. So let's go ahead and fill it in. Here's our number line. And we're looking at it from the 3 points, one at 0, one at positive radical 2, and negative radical 2. And we're comparing it from h prime to h. Let's test some numbers. What number should we test on the far left?
-5.
-5. And then what about far to the right?
5.
5. What about the third and the second one?
1 and
-3. -3? Well, -3, that's going to pass it.
-1.
Why not 1?
Yeah, 1.
1 and -1?
Oh.
Yeah, 1 and -1. Y'all are getting creative and it's not helping you. All right, let's plug it in. If I plug in -5 on here, that's going to make the top one to become a big number minus a small number divided by a negative. What would that give me? The top is going to give me a positive. The bottom is negative. So we're going to get a negative answer. So we know our graph is going down right here. If I plug in the 1, that's going to give me, looks like a negative on top, yeah?
Yep.
The bottom one's also negative, so it'll give me a positive result. So the graph is going up. Let's plug in the 1. What would that give me?
A negative.
A negative over a positive. So that's going to be a negative result. So it's going to go down. And then I have, for the 5, it'll give me some big number, positive. Positive result. So our local minimum and maximum. So looking at this, we have a local minimum at -2 and negative radical 2 and 2. So let's write out. H has a relative minimum at x equals plus or minus 2. You can separate that if you want. And that is because h prime is doing what? It's changing from negative to positive. And then let's mimic that for the relative minimum. H has a maximum. How many maximums do I have on this one? Just one of them? At what number? 0. And that is because H prime is going from what to what? Positive to negative. All right, on part B, Abigail, let's read.
On what intervals, if any, is the graph of h concave up? Justify your answer.
So we're looking at point of inflection here. Our point of inflection comes from our double prime, so we'll need to find the double prime of this one. So let's apply our quotient rule. H double prime of x. We know the bottom is automatically whatever squared. So let's recall. We derive the top, which is 2x. We keep the original bottom, which is our x. What sign separated this one? Minus. And then we keep the top as it is. And then we derive the bottom, which is basically 1. And if we do simplify this, it's actually going to give me 2x squared minus x squared plus 2 over x squared. Uh-oh. Oh goodness, I don't know what to do. And that's gonna give me x squared plus 2 over x squared. So when I set the top and the bottom equal to 0, I want you to look at the top. Is that going to give me a real number or an imaginary number? We subtract 2 on both sides, and I square root the radical that's got a negative inside. Is that real or imaginary? Okay, let's check. So if I have x squared minus 2 is, plus 2 is equal to 0, and x squared is equal to negative 2. And when I square root on both sides, am I allowed to square root a negative number?
No.
So there's no imaginary on this one. So for this one, that's not going to give me any information. But on the bottom, if I set it equal to 0, we know our critical number is going to be at x equals 0. So let's go ahead and put in our possible point of inflection. Here's our 0, and we're comparing from h double prime to the h. And maybe a good number to pick will be maybe negative 1 and 1. So let's kind of plug it in. If I plug in negative 1 on top, I get a what kind of number? Positive. The bottom one all squared is always positive, correct? So we know this one is concave up. The next one, when I plug in the 1, I get a positive over a positive. It's also concave up. So do I have a point of inflection? No, there's no point of inflection because concavity has to change. So it says, at what interval is it concaved up? On both of them. So here's how we write it. Let's write out on this one, h is concaved up at the interval from negative infinity to 0, union 0 to the infinity. And the reasoning is because h double prime is positive. Yep. See if I can zoom out. Is that the bell?